in the cloning,
Mm.
from where we take the cell
Mm.
is nominated as the mother or the sibling or
Oh.
the
Identical, yeah.
identical.
You mean like
Yeah.
this
What is the
cat,
term? Yeah,
the
yeah.
donor cell?
So we take the cell from here,
Mhm.
from this
From this mother,
layer.
yeah, from
This
this.
is also called the mother?
Yeah, yeah, gene mother. I think this
Gene mother.
the gene just have a gene mother. Yeah, I think this is the donor.
Yeah, she's donor.
Yeah.
Gene mother, donor. Lashi, so the offspring produced will be like, like her.
Identical.
No, identical, but it will be female or male.
Female.
Oh,
Yes,
your-
because it's contain X.
Yeah.
It is from
It will be?
Yeah.
X.
No
Contains
XY.
X from mother.
Yeah.
Actually, Lashi, I was, my point was that like if we talk about the nature,
Mm.
in the human or maybe there is a identical twins.
Yeah.
We don't say that this is mother and this is, so we call this twin.
Yeah. Yeah.
I think this
You mean like this gene mother and
Yeah.
this little shoot will be the like
Twin,
twin?
twin.
Yeah,
No,
yeah,
what's-
yeah.
No,
They
no.
can be identical. They can be two because they are eight
Gene
different.
mother.
yeah, instead of mother, if it
Yeah, should be like a twin.
Donor.
Donor.
Maybe
Yeah,
donor,
yeah,
yeah.
yeah. That's true. That's
You
true.
know.
It can be twins because
Hmm?
age is not the same.
What?
They are not the same age.
Donor.
Yeah, not the
They
same
can be
age.
twins
Yeah.
because they are not the same
Yeah,
age.
yeah.
They are different
Actually,
ages.
this is like a mother,
Yes.
right? And
Yeah.
this should be like
because
a twin.
mother
Yeah.
definition is something
Oh,
different.
yeah, like different generations.
Yeah,
Yeah.
oocyte and
That's
or
true. Became mother, old-fashioned ways. That's why the first clone cat had three. Oh, okay. This is just like a clone cat have kittens. Yeah. Anyway, so this is a Korean, South Korean scientist, Snappy, the first male dog clone from adult cells by SCNT. That people also was very exciting. The reason we will talk about later. Family, the Snappy stands next to the male, and its father from which he was cloned. Yeah, it's still like a father.
Father.
Right? Yeah. Yeah. So the mother was a yellow breeder. So here, as cloning technique used is not efficient. It took nearly 2,000 eggs to make 1,000 embryos, all of which produced just one healthy puppy. So that, clone efficiency is very, very lower right now, still very lower. Since, like a somatic cell reprogramming, the mechanism is still not very clear. So that's also, also a bottleneck of the clone techniques right now for all of the mammals. Right, so this is the dog clone is quite difficult, but still got one, right? So after that, there's more than 20, so far more than 20 mammals were cloned by SCNT method. Even like you can say like camel, buffalo, and fur rat, dog, deer, blah blah blah. So this is the Chinese in Shanghai, the greatest work in the 2017, and we cloned the monkeys successfully. So this paper was published on Cell. So the monkey, it's very close to humans, right? So it's very, very difficult. They also did a lot of embryo studies and finally got two and named Zhongzhong and Huahua, two monkeys. Yeah.
Zhongzhong means
Zhongzhong,
China.
Huahua. Yeah,
China
like
flower?
China,
Flower?
Zhong, 中国, like
flower, Huahua.
flower.
花花
not flower. We 中华人民共和国. Yeah, that's also our countries. How to say that? Yeah, 中. Yeah, but Huahua is not the flower here. Okay, the male. So, from published the Gurdon, right? John Gurdon published raised this nuclear transfer idea from John Gurdon and to get finally get a monkey. It's 90 years. 90 years hard work.
Oh,
Yeah, from frog to the monkey. So they published the paper on cell in 2018, and the cover article, they used this monkey to blow its hair to, right now the Chinese scientists, also, contribute to, not only like this greatest, like novel and also from scientific, side. So it's very interesting, very nice work. So why clone mammals? Why clone mammals? So we can, easily to think about the human therapeutic proteins, right? We can, have the organs, tissues for transplants, for, humanized cow milk, animal models for disease, cell therapy agents, or economic traits in livestock. So here, I just give several examples. So if the pigs can be cloned, we can have the, as I said, we using somatic cell, and we do the gene editing and combine and this cell nucleus can, easily make the pig with the SNT method, right? So right now, from the cell work, I have grown my ear blast sample into the cells and do the gene editing, and finally harvest this, have the gene editing takes half of year, 6 months. But previously, we need, maybe several years to produce one pig. So that is speed up the transgenic or speed up the genome editing pace, right? For, this is for milestanding, and you can harvest more meats. So for sure, biomedical research, right? We can do SNT. Why SNT efficiency was so lower? If we want to, harvest more, like harvest more like stem cells or ESCs, and for basic studies, that's very, very important for gene therapy, right? Organ transplantation. So here's for animal model or mammary gland bioreactor. We can, do the transgenic cow and to or pigs. You can have the milk to produce very, very, produce many factor 9, factor, some proteins you very
Insulin.
hardly to get from other sources.
Insulin, like.
Insulin or factor 9, factor 8. And also we can do a lot of, animal models. So basically, for fundamental research that know and about, right? And to look at how development, why it's embryo develop into the individuals for aging, for embryonic development, revealing the function of genes and the nature of life, right? So, okay, and we also think about using this way, if only have one panda in the world, so we can clone the panda, and it's always saving endangered species. Yeah. So and also, this crazy scientist named George Church is a professor in the Harvard University. We will talk about him later on. But here he set up the company for cloning, and they just have the idea, we should to resurrect the woolly mammoth. So from the somatic cells in the eye, in the eyes, and they have this plan and got a lot of money, invested money to do that. Yeah, that's Dr. John Church. So, and another reason is pet clone. So, especially in America, pet was considered their family member, right? So, but their life is about 10 years. After that, when they die, the people feel very, very sad. But if want to clone exactly the same one, so that's possible. And however, for the police dog, you train a very dog, or you find a very top level dog for police purpose. So, if you want to screen a top dog for police purpose, it's hard. But if the clone techniques can produce just a copy this excellent police dog, yeah. So that is used for think about this purpose is quite useful. And yeah, it's clone. This like other techniques. People always think, okay, this new techniques will, what this new techniques bring to people, right? So some people think about the safety problems. So animal cloning is not efficient and likely to remain. So for the foreseeable future, so people always have many concerns, right? So right now, every country in the biological research field, we do have the common agreements that something you can do, something you cannot do. For the cloned embryos, maybe just restricted, strictly like like a very few purpose for example, for disease treatment or for research, but still for research, like human embryo cannot be modified. So that's the common agreement so far. Okay, so this is the questions take home. You can think about, Dolly is quite young when she died. What do you think about its death? Should we clone humans? With human or clone being born soon? And I think if you are interested in these techniques, you can read the, like a monkey that cell paper to think about why, like 90 years later, and the monkey was cloned. Why monkey clone was so difficult, was very difficult. You think about it. Yeah. So I think that's for first section, somatic cloning, SCNT, very basic information about SCNT. So why I talked about this section, because we